Assalamualaikum everyone. My name is Sumya Afroj and my ID is 19301164. Today I would like to welcome you all to our presentation on topic customer review analysis using NLP and data mining. Before we begin, I would like to give a brief overview of what we will be discussing today so that by the end of this presentation you will have a better understanding on customer review analysis using NLP and data mining. So let's get started. First of all, what is sentiment analysis? Sentiment analysis is the process of computationally determining the sentiment or opinion expressed in a piece of text. It is often used to analyze customer reviews or social media posts to understand the overall sentiment towards a particular product, service, or topic. The internet has evolved into primary forum for opinion expression. Sentimental analysis is concerned with automatically ascertaining if a reviewer purpose is positive, negative, or neutral. Information extraction is made possible by the ease of access to all of these viewpoints, which is free. There are several approaches to performing sentimental analysis, including knowledge-based techniques that totally rely on language processing algorithm and lexicon-based techniques, and machine learning based techniques that involve extraction features such as word frequency, parts of speech tagging, and term frequency, inverse document frequency. To improve the accuracy of a sentiment analysis model, it is important to perform data processing such as noise reduction, normalization, vectorization, as well as feature extraction using techniques like n-gram tagging and term frequency inverse document frequency. Text classification techniques and automatic classification system can also be used in natural language processing and text analysis to achieve the desired result. Next, background. Previous research in this field of opinion mining and sentiment analysis has focused on the importance of text processing and feature representation and selection in improving the accuracy of classifiers. Some studies have also examined the use of machine learning techniques such as the naive Bayes method and Waldner's semantic analysis tool for categorizing product evaluation on Twitter. Other novel techniques such as random forest, radial basis fraction, and neural networks have not been fully explored. Some research has also emphasized the impact of data cleanliness on accuracy of sentiment analysis and the benefit of using the bigram model over the techniques like SBM and naive Bayes. Other studies have suggested the use of Epic Spark framework for analyzing Twitter data and have found that decision tree algorithm can achieve 100% accuracy in precision, recall, and F1 scores. Other research has explored the challenges of sentiment analysis, including the impact of review structure, issue nature on evaluation, and the effect of corpus skewness on accuracy. Some studies have also used ensemble classifiers and maximum entropy to classify tweets as positive or negative and based on their sentiment about electronic equipment. That's all from me. Rest of this part will be described by my fellow group members. Thank you everyone.
Assalamu alaikum everyone. This is Nasimuzzaman and today we will be discussing a new method for analyzing product reviews using a database. Our approach involves representing each review as a group of words which can be mathematically represented. We create binary vectors to represent the presence or absence of these words in each review. The resulting bag of words consists of these vectors, which may be sparse due to this presence of many zeros. To improve the efficiency of our analysis, we also remove words with low frequency from the bag of words. We believe that this method will provide a more accurate and efficient way to access the opinion expressed in product reviews. The dataset contains reviews left on Amazon by cell phone users, and our algorithm is trained using supervised learning techniques. Before we can begin training our algorithm, we need to process the text data in the dataset. This involves several steps, including removing reviews with short word counts, translating all reviews into English, changing all reviews to lowercase, removing stop words and special characters, and implementing stemming of words using various libraries. Stop words are words that are used as articles or connectors in English grammar, but do not convey any emotion. In order to remove these stop words from the review, we use the NLTK corpus. However, we do not remove related terms such as not, because they play a significant role in opinion mining. Stemming is the process of reducing every term in the dataset to its root words. This makes sentiment analysis easier because we are more interested in the sentiment found in the text rather than the grammar. We use the Porter-Sweeney algorithm for this purpose. By pre-processing the text data in this way, we hope to improve the accuracy and efficiency of our algorithm for analyzing product reviews. So here is the concept of inverse document frequency and term frequency and how they combine to provide the TF-IDF measure. Term frequency is the number of times a term appears in a document. It can be represented mathematically using equation 3, which has been used in our paper. Inverse document frequency is a measure of a word information density or of its frequency or rarity across all texts. It is calculated by taking the logarithms of the proportion between the number of documents in the corpus and the number of documents that contain the term. Equation 4 provides a solution for calculating inverse document frequency. By combining term frequency and inverse document frequency, we can calculate TF-IDF measure as shown in equation 5. This measure allows us to determine the importance of a term in a particular document within the context of a larger corpus. An n-gram model is a contiguous sequence of n terms form of a given simple sample of text. It is also known as a shingle in text processing. The n-gram technique is a development of the bag of words model, creating a sparse matrix similar to a bag of words but with newly created columns listing both singular words and sets of singular words based on the value of n. For example, when n is 1, the model is known as a unigram model, which is simply an allocation of individual words. When n is 2, the model is known as a bigram model, and so on. In this bigram model of the comment, I read a book about the history of America, the set of distinct terms would include a book about the book history of, I read of, etc. Like a bag of words, the presence or absence of the words is indicated by a 0 or 1. The most rarely occurring words are typically removed from the model, resulting in another sparse matrix. The bigram model uses a technique called Markov modeling to estimate the probability of a word given the words that precede and follow it. To illustrate this, let's consider the sentence "the cat ran away." The diagram of this sentence are the cat ran, and ran away. From these diagrams, we can calculate the probability of each one, which in this case would be 1 by 3 for each diagram. This diagram model is commonly used in applications such as automatic speech recognition and text summarization. It is a useful tool for understanding the probability of a word given its context within a larger sequence of words. Bigram frequencies allow us to identify the most frequently occurring combinations of words in a review by manually selecting the themes that will provide the most insight into the investigation. We can use bigram models to extract two-word combinations from text data to identify the topics of discussion. These can help us understand the sentiment of a review and the topics that the reviewer has discussed. It can provide valuable context and insight into the content of the review. The process of training and testing an algorithm after pre-processing the data. The next step is to train the algorithm by providing it with a small amount of data. The algorithm is then trained to recognize the patterns in the data. Once the learning process is complete, we must test the algorithm's level to knowledge by putting a specific volume of data. It is common to split the data into two subgroups in a 4:1 ratio for training and testing purpose. However, these ratios may vary depending on the classification algorithm being used. After decomposing the dataset into its component parts, we input training data to the algorithm to teach it how to classify the data. There are several classification methods available, including the naive Bayes classifier, the SVM classifier, the decision tree classifier, and the random forest classifier. The decision tree classifier generates a tree-like structure with required classes and the leaf nodes using a series of questions and criteria. The entropy of the data is determined using equation 6 to choose between the tree's root. The naive-Bayes classifier is based on a conditional probability model and assumes feature independence. The probability of the dataset being classified is represented as a vector of independent features using equation 7. The SVM classifier categorizes the input data by creating a hyperplane between the collection of points using equation 8. The normal vector of the hyperplane is represented by W in this equation. Each classification algorithm has its own pros and cons, and their performance varies based on the nature of the dataset. To determine the most accurate method for analyzing product reviews, we apply various NLP techniques to each algorithm and check their performance. When we receive a fresh dataset, we can feed it into the chosen algorithm to determine which class it belongs to, because the algorithm has already learned the nature of the dataset. It is able to produce the most appropriate class for the new data. As an example, let's consider the use of customer reviews of Amazon cell phones as our dataset. When a new customer leaves a review, we can feed it into the algorithm to determine whether it is a favorable or unfavorable review of the cell phone. This process allows us to quickly and accurately classify new data based on the knowledge gained from the training dataset. To determine how well an algorithm has learned about the dataset and can predict the classes of new data, we feed the test dataset to a trained model. This process allows us to calculate the performance of the algorithm. To understand the result of this process, we create a confusion matrix that contains the number of true positive, false positive, true negative, and false negative values produced by the dataset. Using equation 9, we can calculate the false accept rate and false reject rate. Precision, or how well the algorithm agrees with human judgment, can be calculated using equation 10. Based on the accuracy of the algorithm, we can determine whether it is suitable for further prediction. The process of using a trained algorithm to classify new data. When we receive a fresh dataset, we can feed it into chosen algorithm to determine which class it belongs to, because the algorithm has already learned the nature. So the implementation of the proposed approach for analyzing product reviews using various libraries and packages in Python 3.6, including Pandas, Google Translate, NLTK, RE, Matplotlib, Seaborn, and others. We use the Kaggle Amazon cell phone review dataset to train the algorithm and identify positive and negative reviews. For this purpose of experiment, we considered at least 1500 1500 reviews with a maximum rating. Based on the simulation result of these 1500 reviews, we constructed various confusion matrix using different algorithms. So the table 1 shows that Ngram model produce superior outcomes, and the SVM classifier result were superior when compared to the other classification algorithms. And table 2 in the paper displays the confusion matrix produced by the SVM classifier. To further process the data, we used the regular expressions library to remove special characters and numbers from the reviews and converted all the reviews to lowercase letter. Um, we also use NLTK, and phrasing, manually add more words to the list of stop words and phrase through each reviews to remove stop words, special characters, and numbers. Thank you.
Assalamu alaikum everyone. My name is Ahmed Nur Merag and I'm going to talk about the potential challenges, results and discussion and conclusion. Now let's begin. Potential challenges. Consumer review analysis using natural language processing and data mining techniques can be a powerful tool for businesses to understand the sentiments and opinions of their customers. However, there are several challenges that need to be considered when conducting this type of analysis. Data quality. One of the main challenges of consumer review analysis is ensuring that the data being analyzed is of high quality. This includes ensuring that the reviews are authentic and not spam, as well as ensuring that the reviews are written in a language that is easy for the NLP algorithms to understand. Sentiment analysis. Another challenge is accurately determining the sentiment of a review. This can be difficult because people often use subtle or ambiguous language when expressing their opinions. And the sentiment of a review can depend on the context in which it is written. Dealing with subjective language. Another challenge is that people often use subjective language when writing reviews. making it difficult for NLP algorithms to accurately understand the sentiment being expressed. Handling sarcasm and irony. It can also be difficult for NLP algorithms to accurately interpret sarcastic or ironic comments, as they are often written in a way that is intended to be humorous or tongue in cheek. Cultural differences. Another challenge is that cultural differences can impact the way people express their opinions and feelings. For example, what may be considered a positive review in one country may be seen as negative in another. This can make it difficult for NLP algorithms to accurately interpret reviews from different cultural contexts. Overall, consumer review analysis using NLP and data mining techniques can be a valuable tool for businesses, but it is important to be aware of the potential challenges and limitations of this approach. By carefully considering these challenges and taking steps to address them, businesses can more effectively use consumer reviews to improve their products and services. Results and discussion. We used Porter's stemmer to implement the stemming of words in each review. Then we create an empty list by appending all the words in all of the reviews to the list. After applying for loop in Python 3.7, the list now contains 2545 words, some of which may have more than one occurrence. We generated the following graph using matplotlib and Seaborn to draw the graphs of word frequencies. The function called Apexis returns a list of words having a frequency of 1. We find that the length of the frequency is 1279. From this we can remark that a huge number of words occur only once, and hence they will not provide any valuable insight to the analysis. Hence we can add this list to the list of stop words and remove it from the reviews. Reducing the computation time of codes, the length of B is 1266. NLP words contains all the words in the list, stored in a dictionary format with the words as the key and its frequency as the value. The next step is converting all the dictionary to a list of tuples. After that we create an empty data frame and store the values from list D into it. Now we sort this in descending order of frequency, and the following table shows that. At this point, we tried making a list of all keywords. The length of the keyword is 282. Also, we found the number of reviews that contained a particular word from the new list of keywords. Now, we remove all the words from the reviews except the top 100 frequency words by adding them to the list of stop words. The length of the keyword is 100 in this case. To make word combinations, we now import the itertools library. The length of the pair is 4950. From the graph, we can observe the pair frequencies and hence decide the themes to look for in the review. Conclusion: the performance of several algorithms and NLP techniques on a dataset of Amazon cell phone reviews is compared in this study, and the algorithm with the best performance is examined. The SVM classifiers have the maximum accuracy in this case, as we have seen, but there is also a trade-off between FAR and FRR when determining the algorithm's accuracy. As a result, SVM achieves the greatest accuracy, making it the optimum classification algorithm for the given dataset. In order to further improve the performance of SVM, various kernel functions and parameters can be experimented with. In this research, we are looking for information from product reviews to determine what the main drawbacks and benefits are. To accomplish the same, we have used data mining and natural language processing concepts. Python 3.7 was used in this instance. This is the sources bibliography we used to make this paper. Thank you so much everyone for watching this video. Assalamu alaikum.